This is going to kick off our presentations to help you guys get through the CCENT stuff. And the first topic that we're going to cover today is the OSI and TCP/IP model. A little bit of background. Used to be computer networks were, every manufacturer had their own standard for networking computers together. That got to be kind of a pain. So a couple of different organizations decided we were going to create standards. One of them developed out of DARPA, so that is the defense model, is TCP/IP, and the other is the OSI model. Really, this used to be an actual protocol that was used. It kind of fell by the wayside, and TCP/IP was the winning protocol out of the two. But still, the OSI model is referenced a lot, probably because it goes into a lot more detail about how everything interacts. The TCP/IP is what we really use in computer networks every day. And the OSI model, which used to be a protocol, is just now used for reference. So this gives us a framework of how every piece of network communication happens. And we start off down here. We have our different layers of the OSI model with physical, data link, network, transport, session, presentation, application. And over in TCP/IP, we have network access, which can be broken down into link layer and physical, and then internet, transport, and application. So the TCP/IP model is a little bit more simplified, and it's really, in the Cisco world, what we're going to be using, really, in day-to-day situations, because for the most part, everything that happens in the Cisco world happens from here down. Now, when a computer communicates to somebody else across the network, what it does is we start out up here in the application layer, and we have like Internet Explorer in the application layer. And it has to know how to communicate and get its message across, pull information off of a web server somewhere. So, rather than every web browser having a different way of going to web servers, and web servers having to respond in different ways to different web browsers, it's become standardized. So, Internet Explorer comes and it sends a request, and what it does, it sends it down to the next layer, into the presentation layer. And the presentation layer, you have something like HTTP, Hypertext Transfer Protocol. So, every browser is built and knows how to communicate via HTTP. Then that sends it on down the protocol stack, and it sends it down to the session protocol, and it creates a session to the web browser. It creates a session with the web server on the other end of the communication. And that sends it down to either use a protocol called TCP or UDP. TCP is a guaranteed form of communication, and UDP is kind of a send and forget. So, and packets can get lost via UDP, and nobody ever knows. With TCP, the systems realize that those packets get lost and resent. So it recovers anything that's lost along the way. Usually, it's a TCP session. Then after that, it gets sent down, and it says, okay, now we have to worry about what's my address and what's the address of the system that I'm getting something from. Kind of like the post office. You're sending a letter to somebody across the country or in your same town. You have to have an address, your address of where it came from, and the address of where this information is going to, where you're sending the request to. So we tack on an IP address. Now, There were other protocols before TCP/IP like IPX, SPX, and they would add on a different type of address in this case, but almost every network nowadays uses TCP/IP, so that's what we're going to talk about. Now, this is kind of like, the universal address. Every system on the internet has an IP address. And this is what allows us to communicate between different networks. So you have your network at home, you have a network at school, you have a network at, let's see, home, school, work. You have networks in those places, and you have communication that happens within that network. And that all uses MAC addresses within a network. So the IP addresses allow you to communicate between different networks. MAC addresses allow you to communicate within a network. And then we go down and we have the physical, and that is your transport media. Now, that can be anything from a copper wire, such as in the case of Category 5 or Category 6, Cat 3 wire. It can be a wireless signal in the case of wireless. So, this is just a very generic term that can mean a lot of different things. It could mean fiber, it could mean wireless, it could mean copper. Now, a lot of people get confused as to why we have these two different addresses here. Well, within any network, we'll have computers, okay, so these guys are going to communicate amongst each other using MAC addresses. They really don't use IP addresses to communicate to each other. So what they're going to do is, within the network, they're going to use MAC addresses to talk to each other. When they have to go out and get to a web server out on the internet, they're going to say, okay, to get out, I'm going to send this information to the MAC address of my router. What the router does is then it looks at the